Welcome to the Pharmacy Inspection Podcast, brought to you by Visant Consulting, where we discuss topics related to all things pharmacy compliance. Now, please welcome your host, board-certified compounding pharmacist, Seth DePasquale.
So welcome to another episode of the Pharmacy Inspection Podcast, and I've got a very special guest, the former co-host of the podcast with me today, Bryan Prince, and welcome, Bryan.
Thanks for having me, Seth. It's always a pleasure, getting to talk to you again, and I miss our good old days when we were doing the podcast and, having different guests in and talking about different topics. And, that was always good, especially getting when we got feedback from the audience and questions, which just kind of drove it. But, like all things, it was a lot of work, and I think we were both busy, but it's nice to see that you have recreated this, brought this back out. I caught the first 3-4 episodes now. Great content, great guests thus far, and so I appreciate you having me back on.
Oh, absolutely. You're always welcome. And you bring so much to the table when it comes to the main topic that we're going to talk about today. So we're going to talk about clean rooms. And got a few things to cover, but the one thing that I've noticed, and now as a consultant with Visant, I've been on site to several facilities, and I've noticed firsthand that there's just a lot of stuff in the clean room. And you've designed a lot of clean rooms and probably redesigned a lot of clean rooms. So what's your experience been like going into clean rooms and their present state, basically?
And seeing the stuff, you're right. The first rule of thumb that I tell all of my clients is to think minimalist. If it doesn't belong in the clean room, don't put it in the clean room. And some people say, well, what about the IV bags? Well, yeah, maybe 1 day's worth of volume, 2 days worth of volume, but don't put just because you got a shipment in of the IV bags, and they're still in their foil packs, and maybe they're in the ISO ante room, and they have a shelf full of these things. I saw this firsthand not too long ago at a pharmacy, and I'm like, how many days, how many weeks, like what does this inventory of stuff look like? And it wasn't just IV bags, it was other things. And they said, well, this is probably 3 to 4 weeks. I said, well, I'm a fan of not putting this stuff in there because it adds to particle counts, it adds to opportunities for CFUs. You're tearing the foil, you're moving around the bins of needles, and so my comment to the clients are always think minimalist. And so as I'm designing, I give them very little shelving space. Matter of fact, I'm more of a proponent of totes and carts. We honor the dirty side and the clean side demarcation with dirty cart, clean cart. And you only take in what you need to take in instead of using either your ante/prep room or even your buffer room as some catch-all storage, because that's it's not good.
Yeah. The other piece of this and unrelated to the whole contamination portion, but if you have this all set up correctly, you can control your inventory a whole lot better as well. But you have to have it. That's a whole another conversation. Talking about lean Six Sigma processes and procedures with inventory control.
Yep. Just in time. I'm a huge proponent of lean as well. And I know, I've had long, different conversations about that, which is, lean, no doubt about it. And what I'm hearing the pushback on lean, and we won't go too much on a side tangent on this, what I'm hearing about lean and just-in-time inventory is that because of COVID, because of the market, because of things that are going on with the supply chain, and I think we're all tired of hearing about supply chain, but it is a real thing, especially in the medical supply industry, is that pharmacies, hospitals, they're having to order more inventory because they're not sure if there's going to be a supply chain issue. And I get all of that, but it still doesn't belong inside the clean room.
Yeah, exactly. one thing I've also noticed is, I'll look at, because I usually go in the capacity of looking for issues and helping our client correct some issues, and giving them insight on, maybe things that they could do to their clean room, or things that they could do uh, just in general with how they material handling and that kind of stuff. But one of the first things I asked for is their clean room certification reports. And, you know, they can essentially, I feel like the, uh, the person whoever's in charge of the clean room may look at the clean room report and say, all right, yeah, everything looks like it's passed and we're good to go. But if you do a deeper dive on these clean room certification reports, quite a few of them that I've seen, where particular counts are well into like the hundreds of thousands of particles per cubic foot. And that may still be passing, but it's not ideal.
Hmm.
What have you seen with that? Have you kind of ever dove into any client
Yes,
certification
yes, I have.
reports?
Yeah, so as you go through and see the thing that's kind of always been a little bit of a, a problem, which I thought is that industry, which is guided by CETA, and there's some IEST stuff. There's a kind of some guidance that they all have within that, but they haven't standardized certification reports. So the certification report in Texas is going to look different than North Carolina, which is different from Florida, and name your flavor. And even, let's say, even within Texas, 8 different certification companies are going to have 8 different reports. Now, a lot of them are going to contain some of the same data, but there's not a standardization of the process. So you really do have to deep dive. And I think what a lot of pharmacies do is they scroll through and they see pass, 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 good, put it in the file in case some regulatory or accreditation, whoever wants to come by and look at it, right? Then it goes into the file. But you're right, if you deep dive and you start looking at the numbers, and you're on that borderline of that ISO rating, or you see, and even if it's non-viable, you still want to understand why. Okay, or is there excessive motion? And kind of getting back to that lean principle, are technicians moving around too much, going from here to there to get materials, to stage materials, going over to the autoclave and tearing the foil? There's always a lot of motion, and that's what's creating a lot of the particle counts, are the motion. Now, yeah, we can have too much stuff, but let's say that we removed the excessive amount of excess amount of inventory out. The people and the process are what's actually now generating the particles.
Right. Right.
So study the process, study the workflow. It always, to me, boils down to the workflow. And if you step back and you watch, you can see these things.
Yeah, and another thing that comes up into play with this is the air changes per hour, how much volume of air is coming into the clean room, how much is leaving the clean room, where the low wall returns are. I find that there's in several of the clean rooms that I've been in, the low wall returns are either undersized or are in just the wrong place in terms of, where, because you really should be kind of planning all of that out ahead of time before you build the clean room, where your PEC is going to be, where people are going to be, where most of your processes and procedures are going to take place. And, you would want to essentially flush air away from that area using the ceiling filter fan units and low wall returns. And so, what's your experience? Because I mean, you've built clean rooms and placed low wall returns and fan filter units. What's your general like rule that you kind of go by?
Great question, because I could talk about this all day long, but so foundationally, we start with, when we do the floor plan layout, we place in every piece of equipment. I've got a dirty cart, I've got a clean cart, I've got an autoclave and or convection oven, I've got a pre-sterilization weighing hood, I've got a hand hygiene sink, and I lay all of this stuff out, right? And you say, well, wait a minute, what does this have to do with air change per hour? Well, I'm glad you asked. Because once I foundationally lay everything that goes into that clean room, every process, every workflow, and I can step back from it, then I lay out what's called the reflected ceiling plan. And the reflected ceiling plan is, where are the fan filter units? Where are the lights? And how, and then where are my low wall returns and or exhaust, depending on if it's hazardous or non-hazardous. And I tell my clients, I tell architects, I tell engineers, I tell anybody that'll listen, laying out the reflected ceiling plan is a lot like a chess match. And so I don't want fan filter units directly over my hoods or my technicians working in front of my hoods. I do want them in close proximity to, say, a convection oven, if you're using that for deep hydrogenation. And then I want to have a low wall return near that equipment placement that's generating that heat, like that convection oven, right? So I'm making sure that I'm getting good sweep and good dilution. Now, USP 797 states that we must introduce HEPA filtered air at the ceiling. And then there's that strong should or must recommendation that you put those low walls to the floor, because we want to bring that air top to bottom, sweeping. Well, I think you'll find that as you move into some of these smoke studies that we're doing more and more these days, you'll see where they are inadequate to where their placement is, because you'll see dead corners occurring, and that's where you're going to start to grow those CFUs. And so I have this. I tell my engineers on the project, please do not deviate from my reflected ceiling plan, because I went through a lot of great pains to really think through the process. Am I blanketing fan filter, clean HEPA filtered air over the line of demarcation? And then as they move further into the anti-prep space, am I again giving them a dilution point of HEPA filtered air over that space? So I'm creating kind of a blanket or layers, so that I am sweeping the area. I am getting some of that heat gain out of there. And so I told you I can talk about this all day, but it really is a strategic thought process that I don't know that everybody really thinks through on the front side of the design.
Yeah, I one of the conversations that I kind of wanted to bring up, and I just thought this was really, really exciting and cool, is this software that you can use. It's called computational fluid dynamics, and basically what it is you are essentially building a 3D model using engineering architectural software, and then you use another piece of software that will if you put in all the inputs where the HEPA filter units are going to be in the ceiling, where your low wall returns are, where people are going to be, where your PECs are going to be, where shelving is going to be. You put all that into the 3D model and load in your inputs, how much air is coming into the room, what's your requirement in terms of temperature and humidity. You put in all these different components into the software, and it automatically calculates where the air is going. It predictively where the air is going based on what's in the room, and will and tell you where the air is being flushed out. And if it's, and you can see ahead of time without a dollar being spent or anything being built, how your clean room is going to function. And it's just, I thought it was the coolest thing in the world when I first saw it. Have you checked any of this out? And what's your opinion on it? And what do you do you see us using this kind of software?
So my previous life before being a consultant, so let's say that was 2009 to 2015, in that time frame, I worked for an engineered containment company. And what that means is that we designed basically primary engineering controls over unique pieces of equipment. And so Merck and Glaxo and Hospira and Biogen and all of these type companies, there was so many different interesting pieces of equipment. Maybe even like inhalation drugs had these laser pieces. Anyway, there's a lot going on with the equipment. And so we would build containment. To validate part of the equipment, we actually, yes, we integrated what was called computational fluid dynamics software, or CFD. And what that really helped us do was understand, when you place a piece of equipment that has this particular footprint inside of a primary engineering control, and we're trying to move the air in and around it, whether it was personnel protection or product protection or whatever we were trying to accomplish, that tracing that software showed us a great deal as to what we need to know. Do we need to move the equipment further back? And so, and kind of let's translate to what we're doing. I want to pull my hoods off the wall at least 10 inches so that I can clean behind them. So we don't want to push the laminar airflow workbench or the biological safety cabinet completely against the wall, because we know if we were to trace that out, that's going to create eddies and I can't clean behind it, stuff like that. So integrating the software into cleanroom design seems like a no-brainer, except for the cost that's involved. And it's still a very unique thing. Now, there's a lot of software providers that are actually coming out now with versions of this. But I still don't know that it's affordable or likely that it's going to get integrated anytime soon. But I would love to be able to drop my models. And I do all of my design work in 3 dimensions. So first I start in 2 dimension, and I've built a lot of different manufacturers' hoods and the Bender convection ovens and all of the pieces of equipment in 3 dimensions. And so when I place everything in the model, what I really feel like that does is it helps the architect and the engineer and even the pharmacist and all of the technicians really understand all the moving parts and pieces and the functionality of it. But to be able to then integrate CFD on top of that, man, that would be super awesome. So yeah, I'd love to see that pushed a little bit further, but it's got to be more readily available and more affordable.
Yeah. What is, like, ballpark, what kind of pricing are you looking at for, not that an individual pharmacy would go out and do this, but perhaps you're the company that's coming in and building your clean room, for those type of people, how much was the software typically?
It seems like that software at the time, and keep in mind that was almost 10 years ago, I think that software was like a $10,000 software package, and it was also built on other pieces. So now in the architectural and engineering world, they've got Revit and AutoCAD and this huge phenomenal package that will actually simulate like building management systems, and it's a kind of an add-on peripheral to that. Now there are some standalone CFD softwares out there as well, but it seems like at that time there was about $10,000. Now I'm sure that there's a lesser expensive alternative, but to run it on every single project, what would that cost per project? Given the time, I'm not sure exactly even how to price that per project.
Yeah. Just to kind of change things up a little bit, what is your the thing that you like, if you go in on a project and you are asked to clean things up and to do an improvement, either that means either just rebuilding a clean room altogether or modifying what's in place. What are some of the biggest things that you typically do as a consultant, as a designer for companies? Like what's your maybe like top 5 things that you're kind of doing for your clients?
Yeah, so let's say I've got 10 projects right now, and I'm going to give some ballpark hypotheticals, but about 50% of my projects, let's say 5 of those 10, are new construction, design, build, or small remodel projects where we kind of get to start with a vanilla envelope, right? Those are easy. It's the other 50%, which is going to answer your question. The other 5, which I call forensic analysis, and they're always around the HVAC system almost every single time. We can't reach our temperature and humidity targets because they did the wrong engineering calculations. They bought the wrong HVAC unit, or to what you said earlier, their low wall returns are inadequately sized to move the volume of air that they're trying to move. And so engineers use software that would calculate if I need to move 500 CFM in 30 to 45 air changes at this change rate, what does that duct size need to be? Well, sometimes it's right, sometimes it's wrong. Most time it's right, but not all of these clean room projects are engineered projects, right? So you like the one I'm doing a forensics analysis on now is that the HVAC guy and the GC is like, oh yeah, we've done some of these things before, right? And they blew it, absolutely unequivocally blew it. And so then I get the call, hey, we need to figure out what's wrong. So then I get all of their test and balance reports. We call that a tab contractor. Anytime you integrate a new piece of mechanical equipment, you need to have a tab, which is a test, adjust, balance document. Then I'm bringing in the certification professionals. And so I get those two documents, and then I start separating out all of the data, all of the information, and then from a forensics perspective, tell them why the clean room is not performing. And it's because up front, people didn't, I guess, maybe conceptually understand what they were getting into, or jump too deep into the deep, or jump feet first into the deep end. But a lot of my projects these days are forensics of why does this clean room not perform the way it needs to perform.
Yeah. It's we run into the temperature and humidity thing quite a bit, and the temperature and humidity in particular is difficult. Well, I shouldn't say difficult to control, but it's expensive to control.
Absolutely. Absolutely.
It takes so much air being cooled at the right temperatures, being pushed into the space, and on top of that, as the seasons change, so does the airflow in the clean room. So seasonally, of course, you're gonna have to kind of plan ahead for the worst case scenario in the summer and the worst case scenario in the winter. And I think a lot of people are not. I think what's, you tell me actually, what is, like, when you are, or do you have parameters that you tell the HVAC people to spec the clean room out to, or do you leave that up to your client, or what? How does that conversation usually go?
Yeah, I absolutely spec the equipment. I do not leave that to anybody else. And so let me give you an example. USP 797 gives us a strong should for less than 20 C, 20 degrees Celsius. We know that is 68 degrees Fahrenheit. And then it also gives us a pretty solid should on below 60% relative humidity. I take those as a must, and most, I think, accreditations and regulatory do as well. But let's just say it's a hard should. So if I put a technician in a rear tying gown, double shoe covers, double gloves, hair bouffant, and mask, and send them into a clean room at 68 degrees, are they going to be happy? The answer is no, they're not. They're not going to be happy at all. And then if I've got a single stage compressor HVAC unit that cycles, we call it short cycling, where it's cycling on and off, on and off, on and off, then I lose absolute unequivocal control over any humidity control, because if the compressors in the unit are not actively running, then they're not actually then condensing out that moisture and controlling the relative humidity. So newer technology today is where I actually have a makeup air unit that controls both temperature and humidity as independent variables. Now let's go back to those 5 clients that I said 5 out of 10 are new construction vanilla envelope clients. You say to those folks, this is the way we need to do this. And in the very beginning, they're like, oh yes, let's make sure we control temperature and humidity as independent variables, because on our previous clean room, guess what? We had problems. Or I always ask that question. If I were to go back and look at your temperature and humidity logs, would you be within the parameters of the temperature and the humidity an uptime of 95% of the time of the year? And they ultimately would say no, right? We've got problems. So then when I explain to them independent variables, but then when I present the price tag, then they want to start changing their mind. They're like, wait a minute, why can I buy, when my HVAC guy says he can get me a 4-ton unit or a 3-ton unit in here for $9,000? And you're telling me if I want to control both temperature and humidity with this newer great technology and have an uptime of my clean room of 99% and never lose control, that's going to cost me $39,000. Now, do you hear what I just said? 9,000 versus 39,000? Yes, that's a huge price tag. that is what it is. And I wish I made up these prices, but I don't. And that's where I start to lose a little bit of control over the project, because I don't write I don't write the checks to the vendors. I don't write the checks to the general contractors. I can only tell you that if you want a clean room with an uptime within temperature and humidity parameters, and let's just target that. Let's call that 65 degrees, even though USP 797 says 68, I'm going to target mine at 64, 65 because of all the PPE. And I'm going to target that relative humidity at 45 to 50% because that's a sweet spot. That unit, once plotted on what we call the psychrometric chart with the ASHRAE table, specific to the zip code, yada, 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 really deep in the weeds here, that is what comes back as the only solution for you to never lose control over your clean room. And so I don't know if I answered that question without dancing around it a little bit, but I absolutely spec out the equipment. I just don't always get to control what lands on the job site.
Yeah. I just find that a lot of the issues that I run into are where they haven't spec'd out the equipment properly, and you have to tell them that we're gonna have to put another unit on here, and it's gonna be upwards of anywhere from $50,000 to $100,000, and jaws drop, and then you gotta so if we're talking about hospitals, or you're talking about duct work and lots of, like, you're contending with nearby spaces that could be cafeterias. You could be sharing air units with other areas, which gives you little control. That in itself is a big problem, where I've seen a lot of hospitals that don't have dedicated air handling units for the clean room. It's being shared with a cafeteria, or a closet, or something else next door, and it makes the entire pharmacy really cold. Well, why is your pharmacy so cold? Well, it's because we're trying to control the temperature and humidity in our clean room, and we don't have a dedicated unit. And you run into that. I run into that a lot. It's just one of those things. You gotta plan it out ahead of time. Plan it out ahead of time, and save money on the front end, rather than having to go fix it on the back end, and it'll probably cost you twice as much to fix it.
Oh, absolutely. When people were reworking ductwork and stuff like that. And I just want to kind of make a point that I was going to allude to earlier, is that in this business, the controlled environment, critical environment, whatever you want to call it, the ton doesn't mean anything, right? Because your local HVAC guys are going to go, well, wait a minute, what is that, 2 tons of air? Just take the word ton and completely drop it out. This is not your house, right? This is not a single story commercial space where I'm running a retail pharmacy. We're concerned about BTUs, which is the heat gain within the space. And I'm also concerned about CFM. And CFM is a product of the air changes per hour. And so CFM drives it, which is air change per hour, and then BTUs, which is your heat gain coefficient within that space. So people need to take that word ton and just completely get it out of their mindset. And that's where I oftentimes will battle with local HVAC guys and say, stop, we're not talking tons. I'm not concerned about your tonnage. I'm concerned about removing heat and air changes per hour through CFM. And yeah, it's going to get expensive, but man, it's going to get more expensive to keep doing it over and over and over. And again, that's the other 50% of my forensics work, is helping people understand that your HVAC guy brought you an $11,000 unit, and now it's garbage. It won't perform. So just go ahead and take $11,000 and chunk it.
Yeah.
And I hate to be the bearer of bad news, but again, what do my friends at the ACHC call me? They call me Bad News Brian. This is what I do. I have made air conditioners and makeup air units and condensers, compressors, you name it, my life study since 2015 to really understand the why, right? That was one of my number one questions when I started this, is why are these clean rooms failing temperature humidities? Well, this is what it boils down to is, and again, I know it's going to be a budget breaker. I tell my clients all the time is that the heaviest financial lift is going to be in the engineering and the controls and the air handling. Basically, that HVAC side is the largest financial investment you're going to have to make, but it is the most critical, in my opinion. Now, yeah, I've got to make sure that my technicians have got great sterile training. They've got their CEs. I'm going to do, competency assessments. I'm going to write really great SOPs. I get all that. But I'm telling you, if you can't control temperature and humidity in your clean room, you can't have people in there making drugs, and you're not producing any revenue in your business.
Yep. Yeah, exactly. Well, man, we covered some ground today. I think we got, some good advice for people that are either building clean rooms or already have a clean room, working with a clean room, some things to kind of check out, and maybe some direction for you to have if you are having issues. And either one of us, you could call Bryan or I, and we're both happy to help. It's kind of what we do. so yeah. But thanks for tuning in, and I wanted to say thanks again to Bryan for coming on board and having another great episode. Thank you, Bryan.
You're welcome. Thanks for having me, man. Always a pleasure, sir. Always a pleasure.
Take it easy.